What does a professional formicarium really cost? And how much does it cost to produce one at home? What happens if I scale this to mass production and produce at least 10 units myself? That is exactly what we are testing now with 3D printing and a laser. For my ordered ant queen, I decided to simply build a formicarium myself. Unfortunately, my ants did not arrive in good condition. No heat pack was used during express shipping, even though the temperatures were absolutely not suitable. That's why they quickly need a luxurious premium formicarium. The design, briefly shown here in the video, explains the functionality. Years ago I already made some out of wood using milling processes and CNC laser cutting. This time I'm going with 3D printing. Here you can do it properly and professionally. I started this project with 3D printing because while the printer is busy for a few hours, you can continue working on other things. For this print I focused on achieving good surface quality. With modern printers, it's easy to get such clean and smooth surfaces. While my printers continue working in the background, for us it's time to start lasering. I'm using transparent acrylic glass 3 mm thick. For transparent acrylic, a CO2 laser is required. I place small spaces under the corners. Since honeycomb beds are not ideal for acrylic laser cutting, don't have an expensive CO2 laser, then you can also work with a utility knife or a saw and carefully snap the material. After that, use files and sandpaper to smooth the edges and finally go over them briefly with a torch. Everything is possible this way, but it's extremely time consuming. Lasers with a camera are my personal favorites. After the acrylic is laser cut, I move on to my drill press. It has a countersink bit installed, and it's very important to apply only minimal pressure at low speeds. Otherwise, the acrylic can crack, especially when the holes are as close to the edge as you see here. The cost for one acrylic sheet is €1.42. There is a small leftover piece, but it's not large enough to fit another plate. It looks great, and it fits perfectly. Already on the first try. Now it's time to use the heat set threaded inserts. If you've never worked with them before, you'll love them after this video. Just like I love your subscription and your like. I'm using a tabletop heatset insert machine, and you know what's interesting about it? Take a look, several parts of it were also made with a 3D printer. Someone else is doing very similar work and selling it successfully, just like what I'm showing in today's video, and that's really cool. To help you better understand the heatset process, I'll explain it very briefly. For my M3 inserts, I designed a 4.5 mm hole, and why 4.5 you'll see in a moment. I also made one hole 0.2 mm smaller and one 0.2 mm larger for testing. The inserts are mounted, but the depth isn't quite right yet, so I place a few layers of wood underneath. I set the machine to about 20 degrees hotter than my filament's printing temperature. Since this is PLA, I set it to 235 degrees. Now I move the insert into position. It heats up, and with gentle pressure I can melt it into the plastic to the desired depth. This is incredibly satisfying and very fast. In the video you can see the real-time speed. Here are the three sizes compared. The smaller one on the far left had a hole that was too small, so too much plastic was pushed outward. The one in the middle is exactly what I wanted. On the right, the hole is slightly too large, which means the insert could potentially be pulled out. I tested it with a screw, but no, it held firmly, so this size would still be acceptable. From the bottom I can still see all the holes. If the hole is too small, it can get clogged with filament. I've now applied this process to my formicarium, and each finished piece requires 8 heatset inserts. I recently ordered more, and I pay 5 cents per insert. Yes, I buy them on Amazon, which is more expensive. 8 inserts equal 40 cents in material cost per product. Back at my printers, there's still a bit of small hardware added. I calculate those costs as well. At the moment, I only buy filament from bamboo in quantities of 14 or more. Some filaments are only available as refill packs and are therefore cheaper, but I still calculate the price as if it were a full spool. I enter €12, 20 per kilogram. I'd like to repeat that most of my filament is paid for with Maker World points. It's rare that I actually spend money on it. The pure material cost comes out to €2.53. Next, I remove the protective films from the acrylic sheets, and at this stage you should avoid scratching them as much as possible. Oh, and one more thing I almost forgot, I print the water feeder and food tray in PETG. This filament handles liquids much better. I place these in the largest chamber, directly under the opening in the acrylic glass. I installed digital hygrometers to monitor temperature and humidity. Some ant species require higher temperatures and humidity levels than the European species I keep here. I also ordered these from Amazon, although importing them from China would be slightly cheaper for me when buying larger quantities. I pay €1.67 per hygrometer. The acrylic panels and the heat set inserts were prepared specifically for this step. Stainless steel countersunk screws secure the acrylic plate to the formicarium. I bought these in small quantities, which made them a bit more expensive. 8 screws are required, and at 14 cents per screw, that comes to €1.12. The material costs add up, but we are almost at the end. I forgot to glue on the feet at this point. A small distance from the ground has the advantage that if you want to place a small heating mat underneath, it won't come into direct contact with the filament. I use strong super glue for this, and it's more than sufficient for my project. Looks good, doesn't it? I chose this feeding method, a large lid on the top. This allows you to feed the ants easily and pour liquids into the water feeder without any hassle. The exits of the formicarium have 2 different inserts. One is closed, acting as a wall, and the other has a hole that allows multiple formicariums to be connected. As the colony grows, they will also get an arena where they can explore everything. You can place natural materials inside and change them every few weeks to keep the environment interesting for them. With the tube connected, it looks like this. For now, I keep the exit closed since my colony is still in an early stage and doesn't need much space yet. Now it's time for the ants to move into their new home. At the beginning, patience is very important, so the ants can accept their new environment on their own. You shouldn't just dump them inside and stress them out. I carefully attach the test tube to the tube and give them some time. Due to the movement and the foreign object inside the test tube, you can tell they're not very happy about it at first. That's why I stepped away for about 10 minutes. After a while, they began to venture out little by little. I was curious to see whether they would accept the formicarium. It's especially important that the queen moves in voluntarily. After another 10 minutes, they really started exploring, and more ants dared to leave the test tube. Of course, you have to make yourself look presentable when you might meet someone new who you like. I had to leave and came back about an hour later. At that point, they were still using the test tube as their nest and had already carried their trash into the formicarium. Unfortunately, there's also a dead ant visible. It arrived like that when I got them. You can tell by their abdomens that they're still quite small, so it's time for their first feeding. I give them sugar water, simply water mixed with sugar. Here I can also demonstrate how convenient feeding is. You can even place food there using tweezers. It didn't take long for a scout to show up. He went straight to the food. I expected him to immediately inform the others, but no. He stood there for over 10 minutes, enjoying the find. You could clearly see his abdomen getting larger. At some point I noticed him feeding the queen while another ant stood nearby, also taking some of the food. I once watched a documentary that said about every 6th ant is surprisingly lazy. It moves along with the colony, pretends to help, but never actually contributes. Once they realized there was food nearby, the others also made their way over. They really seemed to enjoy it. About an hour later, I checked again, and there it was. The queen had also started moving, looking for a new place to settle. At the time of this narration, all the ants have already moved into their formicarium. It's interesting how you ended up with a 3D printer and now you're sitting here, watching an ant documentary made by your best friend. Kiss.